definitions and ideas. Okay, so first off, a standard deviation is a number to represent how spread out the data is by measuring the average distance each data point is from the mean. Long definition. What we're going to talk about in a second. So I'll get that written down first. All right, you're good, Tyler. How many lines did you need?
3, 2.5.
Oh my goodness. Okay.
It's because you made your number numbing. So.
Number.
Yeah. And then you don't write all the way to 11.
Yeah.
That also annoys me.
Okay.
It goes like write all the way.
All right. It's just let's all be mean to Miss Morale Day today.
I do slants too. Look, I didn't even finish my first line.
Yeah. You gotta make sure it fits.
I used to draw mountains because I couldn't write next to the road. Mine was always very slanted.
That's funny. I like that. All right, so a number to represent how spread out the data is. So it's another way to kind of measure range. So the idea that when we look at those graphs on the front there, the orange graph is really spread out, where the blue graph is kind of crunched together. It's that idea of that range and how things are spread out. But what we do is we measure the average distance. So when you think of that word standard deviation, if something is the standard in class, what does that mean? Yeah, it's like typical. So typical and average kind of go together, standard. What does it mean to deviate? Like if you're deviating from my expectations right now, that makes you a deviant. Yeah, not meeting it, you're going away from it, you're distancing yourself from it. So standard gives us that idea of average, and deviation is that distance. So we're looking at how much each data point is on average away from that mean. Are things scrunched together towards that middle, or are things going to be spread apart from that middle? Okay. All right, we have one more thing to write, and again, it's going to take up a little bit of space, but good news is the next couple of days we have less to write. Okay. If a data point is randomly chosen, I'm going to write small here. It is ... And we're going to combine some probability with what we're doing right now. Okay. With probability, we used some categorizations. We categorized our probability. One was like if it was impossible. What was another category of probability? One was like impossible. No. If it was possible, remember it was either like likely or unlikely. What was another classification?
Possible. That's what I said. No.
Guaranteed or certain. And then there was the one right in the middle.
Never.
Even chance. Yep. Okay. So we're going to talk about this probability. So it's likely to be within one standard deviation. Okay. So it's likely to be within one standard deviation. Okay, so when we come up with that number, that standard deviation number, that's going to tell us that the majority of our data is within one standard deviation of the mean. So standard deviation is going to change depending on our data. So as we look at the blue and the orange graph on the board up there, the standard deviation for the orange graph is going to be more spread out because their work is more spread out. So their standard deviation will be bigger, where the Apollo, the blue graph, the standard deviation is smaller because everything's kind of crunched together more. It'll be a smaller number. Okay, it is most likely, so our probability will even be greater, to be within 2 standard deviations. And I'm going to do SD for standard deviation. So if I pick a random data point, and somebody says, "Is that random? What's the likelihood that data point is within 2 standard deviations?" I could say, "Yep, most likely. Almost all of the points should be within 2 standard deviations." Okay, and then almost certain to be within 3 standard deviations. If it's outside that 3 standard deviation mark, that means it didn't follow the trend. It's not really going with the rest of it. It's either something that's really big or really small. Does anyone remember, what do we call those data points that don't follow or that are really big or really small?
Outliers.
Good, outliers. Okay, so with those standard deviations, we're going to be able to see outliers because they'll be the ones that don't really fit in or don't belong. All right, you're going to get a glue in. If you need to trim it a little bit, you can to make it fit. If you're relatively small like I did, you should be good to go. If you want to trim it, you can, but you can just glue it in as it is if it fits. Alright, so if you can make it fit, make it fit. If you need to trim it a little bit, we do have to write a little bit at the bottom. You can definitely trim this top a little bit.
Why is there so many markers?
Alright, so go ahead and get that glued in. As you glue it in, if you want to take out one highlighter, I'm going to use orange as my highlighter today. So if you'd like to use orange, you can. Or if you just want to grab a different highlighter color. We're just going to use one, doesn't matter which color. So I'm going to use orange. If you'd like to use orange, you can. If you don't want to use orange, that's fine. Use a different color. Just pretend everything's fine. Just I'll struggle today.
Wow. It's okay, I don't like blue either.
All right.
Because I got the color, and usually got one with blue or green, and I took blue.
So as we look at this, in stats, this normal curve is something that you would study a lot. So if you're going to go to college, depending on what you're studying, you might take a stats class, especially like if you're going into anything with science or nutrition or nursing, things like that. Everyone really needs to, most majors require you to take at least one stats class. When you take a stats class, you'll be looking at a normal curve like this, and you'll be finding things like z-scores, you'll be using a chi table, so many things. Okay, so because we have so many things for that, I'm just going to introduce you to this symbol. It's an X with a bar over the top of it. Okay, so it's an X and a bar over on top of it. We call it X bar. Pretty creative, I know. Yep. And what that stands for is the mean, the average. Okay, and the reason why is just because when we use it in different formulas, we don't want to write the word mean every time, so we use that symbol X bar, and that is the same thing as mean. Okay. For standard deviation, sometimes we use this symbol. It's kind of like an O with a little ponytail. Sigma. Not sigma. I know this. I forgot. Or we're just going to use SD for standard deviation. Oh, those mean standard deviation. Why can't I remember what that's called?
I feel like mathematicians are only creative when it comes to word problems.
Only. You're right. All right. So when we look at our normal curve here, where is our mean going to be placed? In which one of these dashed lines? The middle one. This is really bothering me that I don't know. Okay, this middle one. Because in a normal curve, what's in the middle? The mean, the median, and the mode. In this case, we're just worried about that mean. So we're going to put the mean in the middle, that X bar. Sigma. There you go. That's a sigma. In case you're wondering, the Greek letter sigma. Okay, you too.
A what?
Sigma. It's like how pi is...
Sigma, but without the T.
Sure, but it's Greek. So yes, sigma. Alright, so when we move from X bar, when we move out, the majority of our data is going to be within one standard deviation. What that means is if I go one to the right and one to the left, most of my data should likely be within one standard deviation there. So to the right, we're going to add one standard deviation, whatever that number is, that says that most of our data is within that one standard deviation. To the left, we'll do a minus one standard deviation. So when we look at those classifications of likely, most likely, and almost certain, this likely to be within one standard deviation, we're going in both directions. So this is within one. It's one high or one low. So most of our data is in there. That's the majority. But even more of our data will be within two standard deviations. Almost all of it, but not quite. Okay, so if we move out one more, this will be a +2 standard deviation. If we move down one, that would be a -2 standard deviation. Okay, and this is almost all of our data is within this space in a normal curve. Not quite all of it. If we go out one more standard deviation, it's almost guaranteed that all the data will be in between these two lines. Anything that's outside of these two lines is going to be an outlier. Okay? Something that doesn't quite belong. So this is our +3 standard deviation and our -3 standard deviation. All right, so if we take the information that we did earlier in that warm-up, if we had a mean of 65, because that was our average for Apollo, right? Okay, so our mean is 65. Also known as X bar. Our standard deviation, also known as sigma, is 6. Okay, so if this is a number line, because we're doing a histogram, so we're doing intervals, where is this middle number going to come from? Yeah, this middle number is the mean. So if we're thinking of a number line on the bottom here, this would be 65. Now, as I move away from that mean, that middle, that 65, I'm going to be moving in standard deviations to show how much of our data is there. So if I go 1 to the right, I want to add a standard deviation. So I'm going to add 6. So 65 plus 6, 71. Or if I go to the left, a standard deviation, we'll do a minus 6. And yep, we get a 59, like Taylor said. So if we looked back at our information from our warm-up, the majority, almost all, but not quite, but majority of our test scores from Apollo, were they between 59 and 71? Does anyone remember? It was a little bit more and a little less. So it's not quite all the data, but most of the data is in between those two. So then if I spread it out to include even more, we would do a plus 6 to our 71. We go another standard deviation, so 77. And we do another minus 6, 53. Okay, so then it's almost guaranteed, or more likely, that we have most of the data between 53 and 77. But do you guys remember what was our high for our range? It's on the board. For Apollo, we had 88 was our high, and our low was, we literally are like 40 seconds away. Okay, so 77, if I add 6 more, what will I end up at? 83, and almost all my scores would be between 83 and, what's 53 minus 6? 47. So 6 wasn't quite the exact standard deviation, I just estimated it. Maybe a little off. It probably is like 6.2 or 6.3 to really encapsulate all of that. But we could say almost all of our data fits between 47 and 83. Okay, again, that standard deviation, I just tried to make it a nice number for us rather than using a decimal point like it is. Okay, so as we look at this, again, most of our data, most people scored, the majority scored in this part because those are the highest frequencies. Then as we move out, we're adding more frequencies to it. We're adding more data. Most of our data should fit in within those 3 standard deviations. Anything outside of that would be outliers. Because that's really where the word outlier comes from. Fun fact, because it's outside the standard deviation. Whoa. Whoa.